Gaskets installation procedure. Sealing flanged connections depend on many things working correctly together, with all individual components involved contributing to guarantee the desired result: no leaks. The purpose of this training video is to illustrate the steps for a successful installation of a gasket in pipe flanges and equipment, so that the mechanics, engineers, and fitters can ensure ideal performance of the installed gaskets, eliminating rework and leakage of process fluids. The intent of this training is to complement the procedures already followed in many different industries. Attention! Throughout this procedure, we are considering the installation of new gaskets manufactured within the dimensional and constructional tolerances of the appropriate specifications. We assume that the gaskets are correctly selected and are compatible with applications. The purpose of this training is not about disassembling the flanges, nor the manufacturing or specification of the gasket, but rather proper installation of gaskets in bolted joints. It is important, before any action, to always be aware of the fact that the gaskets must be brand new and not previously used. Safety. Always keep in mind an important concept. When opening any equipment, it is essential to carry out a detailed analysis of the state of the gasket that is being removed. This analysis usually allows the diagnosis of abnormal situations that may be occurring in the operation or that might have occurred in the previous installation. It is an excellent indicator that corrective actions may or may not be needed. Follow all safety procedures of the company where the work is being done. If safety procedures are not available, follow the following steps. If the fluid is chemically aggressive, acidic, or caustic, use PVC gloves. Be cautious with environmental risks, such as leakage of acidic or caustic substances. Equipment near low walls, paved areas, or near rivers or forests should be inspected more closely. Have readily available all safety equipment appropriate for the execution of the task. Examples of appropriate PPE include helmet, boots, wide vision goggles, gloves, hearing protectors, and escape mask. Tools needed. Before installing the gasket, make sure you have all the necessary tools. There are specific tools for cleaning and others for tightening nuts. And again, always use personal protective equipment and follow good safety practices necessary to carry out the task. The following tools and equipment are examples to obtain before beginning the installation. Others may be needed: closed wrench, calibrated manual torque wrench, equipment for direct torque control, sockets, high-pressure hoses, steel or brass brush, lubricant for nuts, washers, and bolts, digital caliper, positioners, flashlight. Prepare the workplace prior to the installation. A clean and bright environment is essential. Never perform the service without the proper lighting. Always wait for the authorization to begin the job. The equipment must be depressurized at room temperature and drained. Check and put a sign on the line shutoff valves in question with the following words: "Do not open. Equipment under maintenance." Place identification tag on all sets of flanges undergoing maintenance in keeping with this procedure. Specification. Check to see if the gasket to be installed is recommended by the company for the specific application. The gasket that will be installed must fulfill the conditions of service, such as chemical resistance, temperature, and pressure rating. Preparation. Is everything checked? Then let us proceed. The first step of this process is cleaning and inspection. Remove foreign materials and dirt from the sealing surfaces of the bolts or studs, nuts, and washers. Follow the residue control procedures specific for your plant. Examine the screws or bolts, nuts, and washers to detect imperfections, such as chips or cracks. All nuts and bolts must be of the same material and dimensions. Check if the threads are damaged. Examine the surface of the flanges to find deformations, scratches, deep tool marks, or any imperfection that may diminish the proper sealing of the gasket. Replace defective components that were found. Ask for help if necessary. Learn how to define the type of gasket in respect to the seating face on the flange. Soft gaskets. These gaskets have greater compressibility on the surface of the flange, providing greater capacity to compensate for flange imperfections. Soft gasket products include cut gaskets made out of graphite, T-lon, 24SH, and compressed fiber sheets with thickness greater than 1/16 of an inch. Soft gaskets also include semi-metallic designs, such as spiral wound gaskets and 905 metal best corrugated gaskets. Hard gaskets. These gaskets have lower compressibility on the surface of the flange, with less capacity to compensate for flange imperfections. Hard gasket products include camphor gaskets, ring joints, and cut compressed fiber sheet gaskets with thickness less than or equal to 1/16 of an inch. Check the level of the flange seating face flatness, including flange seating surface circumferential variation and flange seating surface radial variation. Next, you will see a guide on allowable defects on the flange sealing surfaces. Check for pits and dents on the flange sealing surfaces. Check for scratches and gouges on the flange sealing surfaces. Identify the superficial flange finish, assuring that it is compatible with the gasket to be installed. The next step relates to flange alignment, which is typical to pipe flanges. Flanges and respective bolt holes need to be aligned without applying excessive force. Centralization. The maximum permissible tolerance of decentralization is 0.05 inches. Parallelism. The maximum difference of flange surfaces at opposite end is 0.03 inches. Distance between flanges. The final distance between flanges must not require the use of greater than 20% of the final torque force. Hole alignment. The difference in hole alignment cannot be greater than 0.118 inches. Report any misalignment greater than what is mentioned here, requesting specific authorization to continue the job in case you are not able to correct the imperfection. Okay, now let us move to the gasket installation stage. Make sure the gasket's dimensions and material for this application are correct. Inspect the gasket to ensure it is free from defects and that it is a brand new gasket. Carefully insert the gasket between the flanges. Make sure the gasket is centered between the flanges. Once inserted, align the flanges together appropriately and make sure the gasket is not gouged or damaged. Do not use glue or other binding agents on the gasket or on the flange faces that are not specified by TEADIT. If it is absolutely necessary, we recommend using a spray adhesive such as 3M Super 77. For non-metallic gaskets, this application should be done only on one side of the assembly and using the least possible amount of adhesive. Important: please make sure this recommendation is clear. Gaskets must not be reused. The next section considers lubrication of the contact surfaces of bolts, nuts, and washers. TEADIT suggests the use of molybdenum-based lubricants like Jet Lube 550 Extreme, where appropriate. Apply plenty of lubricant evenly on the threads and on the tightening surfaces of the bolts, nuts, and washers. The appropriate amount of lubricant will ensure adequate control of friction, but make sure the lubricant does not contaminate the gasket or the flange contact surface. Now let's move to the section covering installation of bolts. Number the fasteners or the bolt holes with a marker following the tightening sequence recommended in PCC 1 2013, or ask our specialists for tightening patterns. It should be taken into account the number of bolts on the flange and the quantity of tightening tools to be used: one tool, two tools, or multiple tools. Always use the correct tools, such as a calibrated torque wrench or any other tool that can control the applied torque. Install each of the bolts with their respective nuts and washers, and manually tighten the nuts in cross sequence, following the numbering sequence. In case you are not able to achieve parallelism between the two faces of the flanges, you can use a hand tool for tightening until the entire contour of the gasket rests lightly on the surface of the flange. All bolts extend through the nuts by at least 2 threads. Important: the maximum force for this operation must not exceed 20% of the final torque. Washers should be well lubricated to reduce friction with nuts during tightening. The hardness of the washers should be between 38 and 45 HRC. Attention! Consult TEADIT's engineering department for guidance on specific torques to be applied. If possible, keep the torque values with the flange documentation tag. Use calibrated torque wrenches, following the pattern determined and the instructions for each step. Adjust the pressure of the wrench to obtain the desired proper torque for every torque step, according to Torque Procedure PCC1 2013. Always tighten the nuts in multiple steps, increasing the torque incrementally. Important: after each step, measure in 4 diagonal points, using a caliper, the distance between the flange faces to ensure they are parallel. Torque. Step 1. Tighten each nut to approximately 30% of the specified final torque, following the pattern. Make sure the flanges are parallel at the end of the pattern in each step. Step 2. Tighten each nut to approximately 60% of the specified final torque, repeating the same pattern. Step 3. Tighten each nut until reaching the specified final torque, repeating the pattern again. Step 4. Apply the final torque to all nuts clockwise, continuing until there are no more nuts turning, for one full pass. Step 5. We suggest to repeat Step 4 at least 4 hours after installation and before turning the equipment back to operations. Congratulations! With this procedure, you have installed the gasket with maximum safety, and if you have used a product of guaranteed quality, you should obtain the best sealing level possible.